We'll discuss about the symbols of elements. Okay, in previous class we discussed about why do we name elements, atoms and molecules. Now we are discussing about the symbols of elements. You must have realized that chemistry involves a lot of reactions. It will be waste of time to write the full name of the elements and compounds every time to describe the reaction. Okay, so in chemistry we have so many lot of reactions, so it will be a waste of time to write the full name of the elements and compound every time to describe the reaction. To avoid this, we use some shortcuts. Okay, using short forms or symbols for naming the elements is one solution. So in chemistry so many reactions will be there, so each and every time it is very difficult to write the full form of the element. To avoid this, each element is represented by the symbol. Okay, so to avoid this we use some shortcuts. Using short forms or symbols naming the elements is one of the solution. So each and every time to write the full name of the element, it is very difficult. Instead of that, in the place of that element names we should write the symbol of a elements. Okay, so it is one of the solutions to avoid this problem. Okay, over 115 elements have been discovered so far. How do we decide their symbol? So nearly 115 elements are there. So how can we decide that element symbols? John Bergelius suggested that initial letter of an element from its name in English is written in capital should be symbol of that elements. John Bergelius, one of the scientists, he suggested that the initial letter of an element, okay, that should be written in capital form to represent the symbol of elements. Okay, so in elements the starting letter will be there. No, the starting letter we can use the symbol of elements, and that capital letter we should write in the in element starting letter will be there. No, that starting letter we can use the symbol of elements, and the starting letter we should be write in the capital form. Okay, for example, oxygen is one of the elements. So what is the starting letter? O. Okay, capital O, that is the symbol of oxygen. Next, hydrogen, one of the elements. In that, what is starting letter? H. Capital H is the symbol of hydrogen. Okay, so once you observe the table 2, symbol of some elements given: hydrogen H, oxygen O, nitrogen N, sulfur S, carbon C, calcium Ca. So chlorine Cl, chromium Cr, boron B, barium Ba, bromine Br, beryllium Be, aluminium Al, iron Fe, gold Au, sodium Na, potassium K. So here once you observe carbon, calcium, chlorine. So in the carbon starting letter is C, calcium also starting letter is C, chlorine also starting letter is C. So sometimes more than one element name is starting with same letter. So when that elements when more than one element, when that starting letter is same, that time we should take the second letter also has a symbol. So when we are using the two letters as a symbol, first letter we should be write in capital form and second letter we should write in small form. Okay, so carbon starting letter is C, its symbol is C. Calcium starting letter is C, so carbon C, calcium, carbon starting letter C, calcium starting letter C. So if we use the symbol of, if we write the symbol of carbon C, if we write the symbol of calcium C, it will, we may get confusion or not. So to avoid this, we should take the second letter also as a symbol. So in calcium second letter was what is second letter? A. So here first letter and second letter we should take the symbol of a elements. When you are writing two letters as a symbol, first letter you should write in capital form, second letter you should write in small form. So in calcium two letters means Ca. C is capital letter, A is small letter. So like the chlorine. Okay, so chlorine, chromium. Once you observe chlorine, chromium. Okay, sometimes starting two letters also same. That time how can we write the symbol of element? Once you observe chlorine and chromium, chlorine CHLORINE. Okay, CH, first letter is C, second letter is H. Chromium CHROMIUM, starting letter is C, second letter is H. In this first letter, in the chlorine and chromium, first letter, second letter, same or not? Same. So if it is same like that, then we should take the third letter as a symbol. So in chlorine third letter what? L. Okay, so if the two letters also same, then we should take third letter as a symbol. When you are writing that, in that starting letter is capital, and second next letter is we should write in small form. In chlorine, first letter is C, third letter is L. C is capital, L is small. So Cl is the symbol of chlorine. Chromium, starting letter is C, and third letter is R. C is capital, R is small. Cr is the symbol of chromium. Okay. Next, like that also boron, barium, bromine. Okay. Boron starting letter B, barium starting letter B, bromine starting letter B. B same, no? If we use the same symbol for these three elements, we may get confusion or not. Yes. So to avoid this, we should take the second letter as a symbol. In barium, first letter is B, second letter is A. B is capital, A is small. B is the symbol of barium. In bromine, starting letter B, second letter R. B capital, R small. Br is the symbol of bromine. Beryllium, Be. Okay, B is capital, E is small. B is the symbol of beryllium. Next, here iron, IRON. So what is the symbol of iron? Fe. Why Fe? We can write I, no. Why we not written here? Why? Because some elements names are derived from the Latin name. Okay, the Latin name of iron is ferrum. The Latin name of iron is ferrum. Ferrum. Okay, so that's why Fe is the symbol of iron. So what is the symbol of gold? Au. Au is the symbol of gold. Why Au is the symbol of gold? Why? Because gold Latin name is Aurum. Aurum. Okay, that's why Au is the symbol of gold. Sodium, Na. Na we are written. Why like that? Why? Because sodium Latin name is natrium. Natrium. Na is the symbol of sodium. Potassium Latin symbol K. Why K? Why? Because potassium Latin name is kalium. Okay. So usually the first letter of the name of the element in English becomes as the symbol of that element and is always written as a capital letter. Okay. So if the starting letter is same for two elements, then we can use the second letter as a symbol. When we are using second letter as a symbol, then starting letter is capital and second letter is small. About some unusual symbol. This is not the end of the problem. We observe that the symbols for some elements come from their names, but some don't. So if you are told that certain elements have symbols based on their Latin names, okay, so if you observe the previous table too, in that some elements symbols are derived from their name. Okay, some element symbols are derived from their Latin name. Okay, so here some of the elements given and their Latin name given and try to write its symbol. Okay, so look at the periodic table and try to find the symbols of the given elements in table 4 and write them against their names. So element Latin name symbol. Sodium Latin name natrium, symbol Na. Silver Latin name argentum, symbol Ag. Tungsten Latin name wolfram, symbol W. Potassium Latin name kalium, symbol K. Copper Latin name cuprum, symbol Cu. Gold Latin name Aurum, symbol Au. And iron Latin name ferrum, symbol Fe. Lead Latin name plumbum, symbol Pb. Mercury Latin name hydrargyrum, symbol Hg. Okay. Discuss about one more topic, elements with more than one atom in their molecule. Several elements have more than one atom in their smallest constituent particles is known as each molecules in these elements. Okay, several elements have more than one atoms in their smallest constituent particles known as each molecule in these elements. Contain two or more atoms combined together to form a molecule. So many elements that have molecules as a smallest particle. So in that elements more than one atom combined together to form a big particle. That big particle is molecules. So that examples of that elements are oxygen, hydrogen, nitrogen are the examples of such elements. So in this oxygen, hydrogen, nitrogen, more than one atom combined together to form a big particle that is known as molecule. For example, so this oxygen, this is made up of oxygen, nitrogen, hydrogen. These are made up of molecule. Molecule are the smallest particles. For example, a molecule of oxygen has two atoms. We need formula to represent such a molecule in simple way. The formula of oxygen molecule is O2. So in oxygen that contain two atoms. So we can represent the oxygen molecule by O2. Okay, O we should write upside and 2 we should write as a subscript number downside. So why did not we write it has 2O? Writing a formula in this way indicate two separate atoms of oxygen. Hence first write the symbol of oxygen and write 2 as a subject number. So oxygen, it is one of the element. The smallest particle is a molecule, means this is made up of 2 oxygen atoms. So we can represent the formula of oxygen O2. First we should write the symbol of oxygen and downside we should write the subscript number, means oxygen, it is made up of 2 oxygen atoms. 2 we should write downside. Subscript number indicate the number of atoms of oxygen combined to form its big molecule. Okay, so subscript number in oxygen formula O2, no, in the 2 oxygen atoms are combined. 2 is subscript number. The subscript number is saying how many oxygen atoms are combined, like that. Okay, you might have heard about the ozone gas. This gas is found in large quantities in the upper layer of a Earth atmosphere. So this ozone gas found in large quantities in the uppermost layer of a Earth atmosphere. It protects us by shielding the Earth from harmful ultraviolet rays of the sun. So this ozone gas is protect us by shielding the Earth from harmful ultraviolet rays of the sun. So every molecule of ozone has 3 atoms of oxygens. Okay, so oxygen, ozone, it is one of the gas. It is protect us from the harmful ultraviolet rays. So the this is made up of 3 oxygen atoms. So can you write the formula of ozone? O3. So ozone formula O3 means it is made up of 3 oxygen atoms. Discuss about one more topic, atomicity. Molecules of many elements such as argon, helium, etc. are made up of only one atom of that elements. But this is not the case with the most of the non-metals. In non-metals, the molecules contain more than 2 atoms of same elements. So molecules of many elements such as argon, helium, these are made up of only one atom of that elements. But this is not in the case of most of the non-metals. These non-metals molecules contain more than 2 atoms. Okay, in some elements only one elements atoms are the smallest particle, but in some elements molecules are the smallest particles. So mostly in non-metals molecules contain more than 2 atoms of same elements. So the number of atoms constituting a molecule is known as atomicity. For example, a molecule of hydrogen consists of 2 hydrogen atoms. So here the atomicity is 2. So atomicity is nothing but the number of atoms constituting a molecules. Okay, how many number of atoms are there in a molecule, that is called as atomicity. For example, hydrogen. So formula H2. In that how many hydrogen atoms are there? 2 hydrogen atoms are there. So its atomicity is 2. Okay, so atomicity is nothing but the number of atoms constituting a molecule is known as atomicity. Okay, hydrogen, it consists of 2 atoms of hydrogen, means it is made up of 2 hydrogen atoms. So its atomicity is 2. Hence it is known as diatomic molecules. Helium, argon, that exist only single atom. Helium, argon, that is made up of that contain only single atom. So hence they are known as monoatomic. So once you observe the following table and know the atomicity of molecule of few elements and try to write the symbol of the molecule based on their atomicity. Argon, Ar, monoatomic molecule. Helium, He, monoatomic molecule. Sodium, Na, monoatomic molecule. Iron, Fe, monoatomic molecule. Aluminium, Al, monoatomic molecule. Copper, Cu, monoatomic molecule. Hydrogen, formula H2, diatomic molecule. Oxygen, formula O2, diatomic molecule. Nitrogen, formula N2, diatomic molecule. Chlorine, formula Cl2, okay, diatomic molecule. Ozone, formula O3, it is triatomic molecule. Phosphorus, P4, tetraatomic molecule. Sulfur, S-site, octaatomic molecules. Why do some elements may be monoatomic? Why do some elements form diatomic, triatomic molecule? Why do elements have different atomicities? To understand the atomicities of the molecules of elements and compounds, we need to understand the concept of valency. So what is valency? We will discuss in. Now we are discussing one more topic, valency. There are over 115 elements known now. These elements react with each other to form compounds. Every element has a definite combining capacity that determines the atomicity of its molecule. So every element reacts with other elements according to its combining capacity, which we call as its valency. So there are over 115 elements known now. So these elements react with each other to form the compound. So one element is combining with the other element to form the compound. So every element has a definite combining capacity. So that determines the atomicity of the molecule. So every element reacts with other elements according to its combining capacity. It is called its valency. So valency is nothing but the combining capacity of an element with the atom of another element. Once you see the table 6, valency of some elements given: helium, its valency 0, hydrogen, its valency 1, fluorine, its valency 1, chlorine, its valency 1, oxygen, its valency 2, nitrogen, its valency 3, carbon, its valency 4. So atoms of the elements have power to combine with the atom of other elements. This is known as its valency. So valency is nothing but atom of the elements that have a power to combine with the atom of another element. This is known as its valency. So we know that how the compounds will form. How the compounds will form? Compounds will form when the atom of one element is combining with the atom of another elements. So when the atom of one element is combining with the atom of another element, that form a new substance. That new substance is called as compound. So here atom of one element is combining with the atom of another element according to its wish? No. Okay. So atom of one element is combining with the atom of another elements according to this octet rule. So octet rule is nothing but, we know that matter is made up of small particles are called as atoms. So Dalton said these atoms are indivisible. So after some discoveries, we can say that atoms also are divisible, in that so many small particles are there, but the important particles are electron, proton, neutron. So these electron, proton, neutron are the three important subatomic particles. So these electron, proton, neutrons are the present in the atom now. So how this will be arranged? So about the arrangement of this electron, proton, neutron, different scientists, they proposed different theories. In that, one of the model is J.J. Thomson model, Rutherford model, and Niels Bohr model. Like that, different models will be there. So by depending on these models, we can say that proton, neutron will be present in the center of a atom, and the electrons are revolving around the nucleus in circular path. Okay. So in the atom, protons and neutrons will be present in the center of the atom. Electrons are revolving around the nucleus in circular path. So electrons are revolving around the nucleus in circular path, that we can call as energy levels or shells. That are called as energy levels or shells. So these shells are represented by n is equals to 1, 2, 3, 4 or KLMN. First shell we can fill 2 electrons. Second shell we can fill 8 electrons. Third shell we can fill 18 electrons. Fourth shell we can fill 32 electrons. So if in the last shell, if 8 electrons are there, then that will become stable. Okay, if in the last shell if 8 electrons are there, then the atom of that element will become stable. Okay, if 8 electrons are not there, then it is not stable. Okay, so here if in that last shell, if 8 electrons are there, that is stable. No, that rule is called as octet rule. Okay, according to this octet rule, atom of one element is combining with the atom of another element. Okay, so sometimes if in the last shell, if 8 electrons are not there, then atom of that elements, to get the 8 electrons, sometimes losing the electrons, sometimes gaining the electrons from another one. So after losing the electrons, after gaining the electrons, if in that last shell 8 electrons will come, okay, then it will become stable. Okay, so like that atom of the elements, how many electrons that is losing, how many electrons that is gaining, so that number we can call the valency of that element. Okay, so now we will explain with this one example. Helium atomic number 2. So these 2 electrons, it will come in first shell. Okay, n is equals to 1 shell. Okay, so in first shell we can fill 2 electrons, no? Except this helium, remaining all follow the octet rule. So helium atomic number 2, in first shell 2 electrons will be there. So 2 electrons are there, so then it 2 electrons are there. These 2 electrons will occupy first shell, so its valency is 0. How is this valency is 0? We will discuss in next class. Now we are discussing one.